Okay, in this one we're going to see how you can monitor your files or directories with the inotify API of the Linux kernel. And if you've ever wondered how like hot reloading of a website works, or in a previous C++ series I had a command that whenever I saved my C++ file it would automatically recompile and run it. This is how it works, so it's all through inotify. And yeah, you can get all kinds of events. So when a file was accessed, when it was read, read is the same as access, when it was written to, when it was closed, and so on and so on. So you first need to create a file descriptor for this inotify thing, and you can do that with inotify init. So that's gonna create, I don't know, some sort of construct inside of the kernel, which gives you a file descriptor which we can read from. And then you're gonna want to like specify which file you want to watch, and so you do this with inotify add watch, like so, and then you specify the file descriptor of the inotify, you specify a path, in our case it will be foo, and you specify flags, but in this case we won't use it. Then we can just do an infinite loop, which will, yeah, just as long as there is events, we're gonna print them. And the way it works is that you're gonna read from that from that inotify file descriptor, and what is going to be returned from the read is going to be a struct that indicates if it was accessed, modified, this kind of stuff, all kinds of events. And so we need to read from it. So we read from the file descriptor here into the buffer, size of buffer, like so. And then we'll have a struct inotify event, which will be a pointer. And yeah, this buffer will contain an inotify event struct, or multiple of them. So if there is a modify, a write, I don't know, a write and a close at the same time, inotify will bundle those into the same read. So we can do this, and then we can have a little for loop, which will loop over those events. So while the ptr is lower than buff plus len, we can do ptr plus equal size of struct inotify event plus event len. I will explain what the len is after. Maybe I should as well do this. And then we have our for loop, and now we can set the event to whatever is in the buffer, or whatever is in ptr, I should say, like so, and I need to convert this, like so, up. Yes, and now we can finally use the event, so we can, each event has a mask, and we need to interact with this mask to know which event was triggered. So it's in, for example, access, to know when the file was accessed, and we're going to print file accessed, like so. No, cannot type anymore. So, and I realized now that I was absolutely lying about inotify add watch. This is not flags, this is like the mask of the events that you want to watch over. So, for example, if I wanted to watch over in access, I should put in access here. So yeah, let's quickly start with this, and let's run it like this. Of course, it does nothing because it waits for something to happen. If I create file foo, yeah, of course, like I need to run it when the file actually exists, like so. And so now if I echo some data in the file foo, we should have had an access. I wonder why not. Okay, so apparently the echo built-in doesn't access the file, but Vim does. So if I open the file in Vim, we can see that we get a file accessed event, like so. And so yeah, and I'll now copy all the events just so that I can showcase it a bit better. So here is all the basic events that you can get from inotify. So as you can see, there is if a file was modified, there's an attribute was changed, so I'm guessing that's the date. Okay. Oh, yeah, well, I'm not cutting that out, so yeah, I'm coughing. So if you close a file, if you close a file, but it was you didn't write anything to it, if you open, if you move the file, if you delete something, if you delete the file or the directory, something I haven't mentioned is that you can also monitor a directory, and then you will get events on every single file that gets modified inside of this directory. And this is also why there is a moved from and moved to. If you move a file inside of a directory, it will give you two events for where it was moved and where from and where it was moved. To monitor all of those, we need to change the mask, and there is a convenience macro which is called in all events. So that will just monitor all events. And now if we run this and we echo something to the file foo, we should have had something. Okay, it was a very dumb mistake. I just forgot to print the new line, and so all the prints were buffered and never outputted. So let me just add this new line. So now if I do echo something, we see that the file is open, the file is modified, and the file is closed in write mode, like so. And yeah, you can do that a bunch of time. You can see what happens when we go in Vim. You can see that Vim does a lot more stuff. If I close it like so, you can see that that Vim actually closes the file, changes the attributes, and so on and so on, and it also deletes it, which is something that I learned, that Vim, when you save the file, actually creates a full temporary copy of the file. I think that's the swap file, copies all the buffer to it, and then after copies this whole, moves this whole file to the old file. And that's just a way that I'm guessing it's, I mean, I don't know, a very old legacy thing that would maybe happen in old in old hardware, like if there was an electricity cut or something while you were writing your file, that system would ensure that the old copy of the file would still be valid. So anyway, there is a little quirk, is that since Vim deletes the file, that means that we cannot watch any more events on it. So if I redo my Vim stuff and then I modify the thing, and now if I do an echo, you can see that nothing happens. That's basically because inotify is not based on the path, it's based on the inode of the file, which is just an identifier that is a number. And so we basically need to redo this watch when delete self is called. So I mean, that's a bit of an edge case, and you can also remove the previous watch by doing rmwatch, and you just pass the wd like so. And now it should work. So if I do echo the rest stuff, if I do my Vim stuff, it works. Oh yeah, I didn't write anything to it, so I should probably modify it, and then we see that it was deleted, but now, unlike before, I can still monitor the events of it because I did this little reset of my watch. Yeah, so maybe let me showcase now how you can monitor a directory. So let me remove foo, let's make a directory foo. And so, like so, and then we can run it. And now if I touch foo a file A in the thing, you can see that it detects that the file was created and so on. And so an interesting thing is that that I should have mentioned maybe earlier is that the inotify event struct has a name in it, which is that when you monitor a directory, any kind of modification on files in this directory, it will put the file name inside of name. And this name is a flexible array, which is a C99 extension, which I can talk in more length in another video, but basically the length of the name is in event len, and so that's why we need to increment by the size of the struct, but also the length of this name, because it's kind of included in the struct, if you think about it. And so, yeah, let me just add a little thing that says if there is any name, let's print with name something something, so that we can see what happens. So let's do this, and let's do this. And now we can see that we can, yeah, there is the file name in our output. And if I do anything relating to that, we still have the file name. If I touch foo b like so, we can see that we have the something with the file b. If I move a file from A to C, for example, we can see that we have the moved from and the moved to events. So yeah, that's about all there is to inotify events, at least for the basic stuff. I hope you learned something. And oh yeah, there is also a command line, by the way. So if you want to make a quick shell script instead of having to write C code, there is inotifywait, which yeah, just waits for events, and using that's what I used to do my little compile and run on save command that I used in my C++ series. So yeah, I hope you learned something, and I'll see you in the next one.